Okay. So as you know, Sunil's doing our chat tonight, and I have the pleasure of introducing him. And he sent Jim a bio in third person, so I'm just going to read a bit of it out. So Sunil studied chemical engineering at university, but didn't become a practicing engineer. He got sucked into the world of advertising and digital marketing instead, and worked in that industry for 20 years, or 20 plus years. Um, then he says he got his pen license at the age of 8, and then has been using fountain pens ever since, starting with cheap, leaky schoolboy pens and graduating to the Safari and the Rotring Isograph at university. He then started his business in the pandemic. So he took up pointed pen calligraphy. I don't know actually what that is, pointed pen calligraphy. So if you want to share a bit more about that, I'd be interested to know. As a mindfulness exercise, so I completely agree with that as well. I use my pens and writing as a mindfulness and a therapeutic thing. And then he learned, sorry, my screen has just gone out. So after learning the hard way that open ink bottles and little kids don't mix, he figured out the obvious solution was FlexNib. So I guess that's a closed cartridge converter pen. And he was surprised at the limited options and high cost and long wait time. So that makes sense. We all kind of look after FlexNibs as well. So everyone's on the lookout for something new. And then he decided to make his own pens. One thing led to another, 3D printers were involved, and suddenly he had some prototype pens, which we were all now lusting after in the group. Okay, so as he said, the Good Blue was set up in March 2021, and he tried and shared the love of Flex while creating a business and a brand. Sunil, do you want to talk about the prize that you have for today? I believe we discussed it would be the prototype pen. Correct me if I'm wrong, but
well, absolutely. You've taken me a little bit by surprise because I did offer up 2 options,
okay.
and I did, but that's perfectly fine. And essentially, what I wanted to suggest was in the coming week, as I was saying just before we started, I'm doing a little bit of testing, different materials, different surface finishes, and so on. And there's going to be some pens or pen-shaped objects that come off the back of that. So.
The other option was nibs as well, weren't they? So
yeah. So, but I think that's really cool, and I'm super happy to do that. So I think the prize will be something roughly in this shape, but in a 1-of-1 surface finish in color. So that should be exciting, and there'll be a good few choices. So I don't know the logistics of how we can sort that out, but happy to offer up some choices for whoever the winner is to pick.
Yeah. And the second prize will be one of another bottle of the Robert Oster ink that we've got as for the FPUK group.
Can I get that as a speaker
yes,
prize? Because
so yes,
it looks amazing.
We've organized it similar to last year. All the speakers get a bottle, so all the speakers will get a bottle. So
amazing.
In that case, I'll hand over to you. I'm recording. I have pinned, so continue.
Brilliant. Listen, thank you very much, Apurva. That was really kind, and I just thank you to everyone for joining. I was saying a few minutes ago, I'm amazed that everyone is able to give their time to listen to me, and I still have a little bit of imposter syndrome. I'm quite new to this entire community, so thank you for taking the time to listen to me. That's absolutely amazing. What I did want to talk about a little bit today was just innovation and kind of asking the question. And I'm new to sort of collecting fountain pens and really getting into it in a big way. It's maybe been a couple of years, although I've always used a fountain pen. And it's just absolutely amazed. One of the things that's absolutely amazed me is how few options there are the moment you just slightly stray off the sort of mainstream. And I'm talking about things like, OEM nib manufacturers. I'm talking about the innovation that's happening in the industry, whether it's with filling systems, with types of nibs, etc. And there's stuff that's kind of creeping in from the edges, which is really, really interesting. So you see a lot, for example, a lot of nib meisters these days doing some fantastic experiments. There's folks in the group as well. Jose comes to mind, for example, doing some really interesting and cool things with nibs. There are a lot of brands that are smaller brands, particularly that are experimenting and innovating. But when I came to it, I was a bit surprised at that. And from a commercial perspective, it also looked to me like there were quite a few opportunities, commercial opportunities in the space. So I wanted to talk a little bit about that today. I wanted to talk a little bit about how I machine pens. I think hopefully that'll be of interest, and just stop and challenge me with questions, because what I think is super fascinating, as Apurva said, I trained as an engineer, but I haven't really been a practicing engineer until literally this year. And you look at everyday objects, and you just take them for granted. Whether it's your iPhone or whether it's cutlery that you're using every day. And sometimes when you stop and think about what goes into manufacturing it, you might find yourself being quite surprised at the complexity or the number of moving parts required, or the number of things that really just need to align for that object that you take for granted every day to sort of appear in your home. So I thought from that perspective, it might be interesting, since all of us use fountain pens and enjoy using fountain pens, to get a little bit of a flavor of how different people make pens differently. Um, and then right at the end, I was hoping I could do a little bit of getting started with Flex, because that was one of the things that brought me into the hobby in a big way. And it was something that I was kind of trying to figure out on my own without a lot of help. I hadn't discovered groups such as this one yet, and I was just trying to figure it out by hacking things myself and by watching YouTube videos. So if there's a little bit that I can share that maybe might be useful, that would be awesome as well. Also, as Apurva said, I've spent a lot of time in the corporate world, and the only way I know how to do a Zoom call is with a PowerPoint presentation. So I'm going to share my screen. Um, and I've got a few slides that I think might be useful just as a show and tell. Hopefully everyone can see that, and somehow I can get this up to full screen too. Yep, so can everyone see my screen? Amazing. Brilliant. So yeah, I mean, I did speak about this a little bit, and just one of the things that I learned at university that I really carried with me through my life was this point about getting really excited about getting under the skin of what you see as an everyday object, and getting quite fascinated about how it's made, and what problems need to be solved along the way. So there's kind of my take on that. And I think the rest of it Apurva covered off, so I'll move swiftly along. And here's the summary, in case you're bored of listening to me for a while, or if you have to drop off. These are the three things that I really wanted to leave you guys with as takeaways. I think what's been amazing for me, and I've been doing, digging under the skin and doing a little bit of research, is just and understanding the numbers, is just the fact that there is a healthy interest in fountain pens, and also that interest is growing, right? And it's one of these things that is kind of non-intuitive or non-obvious. I mean, of course, I'm preaching to the choir with this audience, but more broadly, because you think in a digital world it's such an analog tool, but I feel like there's a lot of objects that sit in this space, and it's kind of this space between engineering and art, or engineering and creativity, really, where if you want something to work absolutely precisely, reliably, and exactly the same every time, you reach for a ballpoint pen, right? Or you just type something. And I think part of the beauty of using fountain pens is that unpredictability and the energy and effort that you've got to put in, because there's so many variables involved in getting that ink to paper. And there's so many dependencies, the humidity in the room, the temperature, the angle at which you hold your nib, the angle at which your hand is to the type of paper that you use, ink that you use, so many things. And I think that's what makes this super fascinating. And one of my other passions is brewing coffee, and it's exactly the same there. It's this analog process, and it's kind of the zen of being in that moment and producing that cup of coffee, or producing that perfect line from your pen. And I feel that there's people just kind of wired to that. As human beings, we're wired to that kind of thing. And more and more in the modern world, you see less and less of this. Everything is made predictable, and everything is made standardized, and everything is made. And I think it's beautiful as an end goal, as a quest. But I think there's beauty in these little analog things, and the journey. So I think that's my point about why fountain pen interest in fountain pens is growing. I think innovation will help the cause is the other thing that I really want to, it gets me really excited. And again, as an outsider to fountain pens until this year, maybe really, or last year, the first thing that I do when I see something is I ask why. Why is it made this way? Why are feeds shaped this way? Or why are we using ebonite? Or why are nibs designed in a certain way, or whatever it may be? And I think those are some really interesting questions, and hopefully I might encourage some of you to start thinking about. I'm sure you are already, but start thinking about some of these things. And the last point that I wanted to make was there's this perception that manufacturing is really challenging or marketing is really challenging, and things are super overcrowded or super complex. But I think given technology and modern manufacturing methods, it's actually surprisingly easy to get started with manufacturing a product, whether it's a fountain pen or whatever it may be. And it's not as capital intensive as you might imagine from ideas from the 1980s, where you've got to go to a bank and get your company capitalized, or have some source of investment and start with £1 million before you can do anything. And just as a point of example, I mean, I started the Good Blue with £3,000, just a little bit of my own pocket money, really. And then off we go. So I'll talk about that a little bit. And so that's kind of in a nutshell, these are the three kind of takeaways from my perspective. And here's a little bit of a history in my mind. The vertical axis here shows number of fountain pen users, and the horizontal axis is time, and the big blue square, I should say, on the left hand side is the olden days. So however you define a fountain pen, whether it had to have a slit in the nib to be first called a fountain pen, or whether just having a reed was enough, or it had to have an ink delivery system which was closed. As it may be, in the olden days, there was some stuff and there was some slow growth, and things were made by hand one by one. And then, really, the steady innovation and growth in fountain pens came in the 19th century. There was more people that were educated, there was more people that were writing, there was more demand, and to address that demand, and because there was a little bit more industrialization and automation in manufacturing, you start to see that curve going up. And then the orangey peachy kind of box on the right hand side, that's really kind of, I don't know, the heyday of fountain pens, maybe the 20s, 30s, 40s. Ballpoints hadn't quite hit the scene, everyone needed to write. And fountain pens were being produced by the millions, and across the entire spectrum of price. And there was a huge amount of innovation, and there was a huge commercial interest in innovation because there was incentive, right? And then we kind of somewhere in the 1950s maybe hit what I'm calling here peak fountain pen. And then guess what? The ballpoint pen came along and ate our lunch. And there you go. That's, for most people, that's the end of the story. But there's a little uptick to the curve right at the end. And I think, that was the point about, the hobby and about mindfulness and about people actually sort of intrinsically as human beings wanting some of that analog experience and wanting to have to invest to get, invest energy and time to get some kind of gratification rather than, just pressing the button, paying some money, and, everything works perfectly. So that's kind of the what's going on here that I'm quite interested in from a commercial perspective. So here you go, the central dogma, the ballpoint pen ate our lunch, and that's the end of it. You ask people, why don't you use fountain pens, or how is it that outside of this group in your day-to-day life, you don't come across people randomly using fountain pens, and every time you do, it's like it's a bit of an event. And here's the answer, right? And then if you start to dig a little bit, you talk to people, maybe you talk to some of the manufacturers or people who've used fountain pens for a long time. They give you this commercial reality, right? They tell you, oh, look, man, ballpoint pens are, I don't know, 10 to the sixth larger than fountain pens in terms of number of units sold. Or they tell you, it's just a hobby, it's fine. Or they tell you, there's 3 or 4 large manufacturers, and they kind of have a stranglehold because the market is small, and amongst them they control 80 or 90% of the market share. So it's not really something. Think about it, somebody who's wanting to invest money, a private equity or a house or something like that. Yeah, not interested, pass, thank you very much. There's very little return, and certainly from a research and development perspective, there's very, very little return on any investment. That's the sort of common perception, the commercial reality that most people see when they look under the skin of this space or this industry. But there is a real reality, and this is what I've been learning in the last 6 or 9 months, right? I think what's fantastic now that wasn't true even 10 or 15 years ago is that anybody can get visibility and reach, right? So marketing has got super simplified, and it's quite easy if you have a brand or a product to bring that product to market and to reach your audience. When I say quite easy, I mean compared to trying to do exactly the same thing maybe 10 or 20 years ago, right? And also from a cost perspective, it requires much less investment. The other point is that technology has democratized manufacturing. So I was kind of making this point earlier, where you don't need to capitalize to the tune of several million pounds to start a factory to manufacture fountain pens. Pretty much everything can be outsourced. Everything is, when I say outsourced, I mean the manufacturing. And it's super accessible. There's industry that's actually set up to do that. A lot of it is digitized, so you don't even have to go down to somebody's factory to meet them. There's a little interface on your computer. You just go in there and off you go. Boosh. Let's get, I don't know, 500 of these parts, made on a CNC or whatever it is. And a few days later, they show up in a little box in your house, just like Amazon. So it's massively democratized. You really don't have to spend. There doesn't need to be a capital investment. I think the other thing that's very fascinating is that consumers more and more are getting sensitized to provenance, right? Nobody wants to be part of that story where they're giving money to Jeff Bezos so that he can, launch his phallic-shaped rockets into space. I mean, have you seen that thing? It really looks very phallic. Does it need to? Um, yeah. So I think that's something that people are starting to realize more and more. And I think if you're a new entrant into into any market, I think that's something that plays to your favor that maybe 10 years ago didn't. And I think the final point is, we want new stuff as fountain pen enthusiasts. We want to see new stuff. We want to see stuff that's different, that's innovative, whether it's something as simple as a surface finish, or whether it's something as innovative as functionally something different, or the audience wants it. So all these things, the antithesis of the previous slide, point to the fact that it is commercially viable to start a fountain pen manufacturing business. And of course, the small caveat I will say that having just done this start a fountain pen business, a lot of this is post rationalization on my part. So all pinches of salt and so on. So that's kind of my background, and that's kind of my background thinking, really. And as Apurva said briefly in the introduction, I started out during the pandemic. I got little kids at home, and the whole day was super busy with all of us cooped up in a little London flat. Usually not all in the flat at the same time. Everyone's off. And it was super stressful and super frustrating trying to get two different aged kids through their homeschooling while trying to manage work, and my wife managing her work. And I needed something to sort of decompress in the evenings, otherwise I'd lose my mind. And I started with pointed pen calligraphy, and for those who don't know, it's essentially dip pens. So you have like a nib holder. Essentially, it's just something ergonomic to hold that has a little fixture at the end where you can put nibs in. And pointed pen nibs essentially are shaped like fountain pen nibs, so they have two tines, and they end at a point, at a very, very fine untipped point, really, for the most part. And you just dip this little thing into a bottle of ink, and then the nib itself on the underside of this undersurface of the nib holds some amount of ink, and off you go. And kind of by default, these nibs are designed to flex, so you do get a significant amount of line variation. And it's a very slow, mindful, careful process, and everything has to be just so, and so on and so forth. And this was fantastic for me, and it just helped me to decompress at the end of the day every day. And I started doing this more and more, and it started to become a little bit of a challenge, as I was kind of flippantly saying in that intro, where it takes a lot of time to set up, and you've got to set up your desk, and you've got to have your ink bottle, and you've got to be ready for spills, and so on and so forth. And I thought in my mind, surely we can cram one of these nibs into a fountain pen. And that's kind of where I went into the rabbit hole and started looking on YouTube and doing a little bit of research, and discovered that people were cramming these zebra G nibs into these relatively low cost Chinese pens, like the Jinhaos and so on. And I started playing with some of that stuff, mixed results, and I thought in my mind, can I make this better just for myself? And then I found somebody had actually somewhere um, uh, uploaded a design, open source design for a 3D printed fountain pen. So I said, cool, let me try that. I printed the pen myself, tried to fit one of these Zebra G nibs in, couldn't do it. The radius of the nib was wrong. It wouldn't sit flush with the feed. I was using a standard number six, maybe a Jovo feed, I don't remember. Um, and so I started looking for other pointed pen calligraphy nibs and found some that actually had a slightly different radius, which fit. And I was like, okay, brilliant. And because I was already down the path of having 3D printed this pen, I thought in my mind, it looks a bit boxy and ugly. Maybe I can make another one that looks a little bit nicer for me personally. So I did that, and then I started talking to a few people who shared some interest in calligraphy, and they were like, "Oh my gosh, can I have one?" So I printed a few, and I mean, pretty much as many small businesses start, a couple of people started feeding back to me, "You should sell these. You could make a few bucks." And I was like, "Thanks, I've got a day job, and it's not really something that I want to do." Um, and they weren't really they kind of prototypey. They're not really finished products. But I did get interested in it for a variety of reasons, and I did have a little bit of time on my hands. So I started playing with it. I started looking at different 3D printing processes. So interestingly, there's a whole different there's a whole bunch of different additive manufacturing technologies that build things up and 3D print things using totally different technologies. So there isn't just one 3D print and off you go. So I started playing with some of these, and started looking a bit nicer. And I started noodling with it, doing a little bit of a commercial plan in the background to think, could this be something that I could do? And kind of one thing led to the other. And as I got more into the rabbit hole, I discovered CNC machining, and pulled out a few old engineering textbooks to remind myself of a few things. And kind of that's kind of where I ended up. I started around February, March this year, and the first products that we actually brought to market to sell was, I think, towards the end of July. And that's kind of how July this year, and that's kind of how I got started. So I'm just going to spend 5 or 10 minutes really quickly. I should actually keep a view on the time as well, because I don't want to get you guys super.
There's a question as well for you. How did you get to the name The Good Blue?
um, yeah, okay, that's a nice question. So my name is Sunil, and I'm originally from India, and it's a Sanskrit name. Um, and all names in India have a meaning. It's not just a name that comes from somewhere. And if you split up my name into the two syllables, so and Neil, so translates as good, and Neil is a color, blue, kind of a dark blue. So it's just a literal translation of my name. And yeah, there you go.
There's another question as well. So the dip pens that you used, are they compatible with fountain pen ink, or do they need more viscous inks? So I know personally that some of them are, but which ones did you use?
Yeah, so I mean, for the pens that I manufacture, they're out and out fountain pens. I would recommend to only use fountain pen ink. In fact, you probably don't want to use any, or you want to try and avoid pigmented inks. Certainly, anything that's heavily pigmented, and anything that has particulates in it. It's exactly the same disclaimer as you'd give anyone for a fountain pen. So, having said that, I mean, we've all been playing the alphabet game recently, and the little envelopes that we got from Rob were kind of brown craft paper. So I've been writing with Diatramentis Document White, which is an absolutely terrible ink that I would not recommend to anybody to put in their fountain pen. But I have been doing it, and I mean, it's perfectly fine. There's no problem. It is, you need to be a little bit more patient with the pen, as with any pen, I suppose. If you're using an ink, it's heavily pigmented, by the way. And yeah, I mean, you just need to be mindful to thoroughly clean the pen. Take apart the nib unit completely and clean the pen very, very thoroughly after you're done, rather than just leaving it in a cupboard somewhere and you come back to it 2 months later and then you're in trouble.
Thanks.
Was it
I didn't see any more immediate questions, but if someone else wants to unmute themselves and ask, you're more than welcome to.
brilliant? Let me just whiz through the next few slides, and yeah,
Yeah.
please interrupt or just pop your questions into chat for Apurva to flag to me. So I make small batch pens that I manufacture locally in the UK, with manufacturing partners. And as I was saying earlier with the business, I don't own any machinery or equipment or manufacturing thingies of any sort. So everything, from the CNC through to the boxes, through to the nibs, feeds, everything. It's about finding the right, for me, it's about finding the right partners, working with them as closely as I can, and getting stuff made. And, yeah, that's basically what it is. And it is very much small batch at the moment, because I don't want to inject a huge amount of capital into the business. I don't want to capitalize the business externally, and lose control of the direction. And it's super super early days, so I'm still getting a feel for the audience. And I was saying earlier to somebody, I still have imposter syndrome. When someone buys my pen, I'm like, wow, are you sure you want to buy one of those? um, but philosophically, and from a what are the founding principles or what are the ideas, it's very much about precision engineering. I get super excited about that. And it's very much about the ink delivery system. And for me, this sounds very cliched or flippant, but it's really about the line. And I get really excited about the kind of line that a pen produces, and maybe a little less excited about what a pen looks like. And if I'm happy with that writing quality of the pen, then I'm even to some extent able to sort of forgive it for certain other things that ergonomically might be important, might have otherwise been important to me. um, and then the other things that I'm super keen about in my personal life that I wanted to bring to the business was about being as local as possible. And again, from a technology is democratized angle, there's absolutely no reason why things should be manufactured 5,000 miles away from where they're intended to be assembled or sold or used. I think that's extremely antiquated. And I see a lot of pen companies, but a lot of companies in general that make things elsewhere than where they assemble or where they're based or where they sell from. And I just think that's absolutely outrageous. It's old fashioned. It's very 1980s. There's in the UK, as in Europe, as in everywhere else in the world, there is this democratized availability of manufacturing and technology that allows you to just as easily make these pens. And what's been absolutely superb and crucial for me is being able to go into the machine shop, hang out with the CNC guys, and be super hands-on with how these pens are made, rather than have somebody far away at the opposite end of the world, and you send them an engineering drawing and you get some sample pens back, and you send them some tweaks in drawing and you get a production batch back. And you're completely removed from that process. It takes a long time. You can't innovate quickly enough. You don't understand the little nuance of machining that impacts your design decisions, your ergonomic principles, and the sort of form of the object and so on. So having these things really closely knit is actually beneficial. It's not just a marketing thing to say, made in the USA or made in the UK or Japan or whatever, versus made in, the Far East or something like that. And the final point here was just to be super sustainable. And, again, that's something that really bugs me. And I've spoken to a lot of people in the fountain pen business who told me you can't avoid plastic, Sunil. You have to have foam inserts. How are you going to protect your pen? You need to have bubble wrap in your envelopes. I mean, it's not just. I'm not picking on, on the fountain pen industry. This is kind of quite ubiquitous, and I think pardon my French, it's bullshit, right? It's. I think it's just lazy. And so for me, you know, uh, we use upcycled felt that's made from wool. It comes from Manchester, and there's somebody who does woolen garment manufacturing, and they have all these little offcuts from the wool and little bits of thread and stuff that they collect in this really big box, and they compact it down. They have these machines that compact it down into this felt, and it's actually sold for pennies as insulation. And we buy it off them. We get it die cut into the shape of this box, and you know we don't have any petroleum products as a consequence in the packaging. And I mean, I don't want to lecture about why foam is bad, but it's bad. And it's the same thing with the tins, the stuff that's made locally, stuff that's made from recycled materials. You don't need to be using plastic, and that's something I didn't want to do with the business at all.
There's a question that relates to this as well from Jackie.
Sorry.
She said, does your business plan include targeting the green aspect of the fountain pen? So I guess you've answered some of it, but
I mean, from a marketing perspective, I do mention it, and there's a lot of greenwashing, right? Like everybody these days has a page on their website that talks about sustainability. So I don't make a huge deal about it. If someone asks, I say, and I'll put it somewhere in a bullet point on a page on the website because it's important to me. But I don't market it as we're a green business, buy from us. Look, we're selling you pens, you should buy them because you like them. But I think you should consider, not to preach or to market here, but I think in general, whether it's pens or whatever, it's interesting to think about what the impact is on the wider environment. So I think it's a commercial business. I'm trying to set up and run a commercial business. So it is about maximizing shareholder value, and the principal shareholder is me. So hey, but I think kind of I've done things very, very differently. So most fountain pen businesses will typically hire someone, a product designer who's super experienced. But I kind of came at it very much from a outside perspective, designing these pens myself, and I've no very little knowledge or experience of fountain pens apart from just the usual bog standard obligatory brands that I've used myself. And I think that gave me a really interesting sort of license to try things that might have otherwise been quite dogmatic. And this is how you make a fountain pen. I spoke about sourcing locally. I think that's super important. And again, I think it's not so much from a marketing perspective, but it's just pragmatic for a business. It's faster. It's oftentimes cheaper, surprisingly, and you're more involved in the business yourself. You're more hands-on than if it's done far away. Um, and I think the other thing that I see a lot in the fountain pen world, as more broadly as well, is loads of ideas and loads of renders and pictures of pens, things that have been 3D modeled or whatever, and very little actual action. And for me, I want to run this business as professionally as I can, and I want to have super tight project management, a really clear quarter by quarter plan of what I'm going to do, and some kind of understanding of why I'm going to do what I'm doing, not just reacting or responding to the market, or just being kind of reactionary to things. And then the other thing that I have learned professionally that I've applied here is just being super focused on the core business. And it's very hard when you run a small business because you're the guy who sets up and runs the website, you're the mail room, you're the guy who does the packaging and posting, you're the guy who's doing the customer service. But my philosophy has been put all or as much of your time and money as you can into product development, and just do MVP, like minimum viable product, for everything else. So is it a great website? It's pretty shit, actually, my website, but does it work? Yeah, it works. Can you buy products? Yeah, you can. Brilliant. And it's the same with everything else. Can I get a slightly better rate on my shipping if I negotiate, or if I, switch providers, for Europe versus for, the US versus for, locally within the UK? Probably I can. But again, the time and effort and the hassle, and then integrating all of those APIs into the website and blah, blah, blah. So you see a lot of businesses where small businesses where the owners, or this there's a single person, they kind of get lost in that chaos. And for me, it's it'll come, and when it comes, I'll do it. And the thing that's been central, and again, it's a bit kind of obvious, and everyone says it, but just actually listening to customers rather than just saying, we listen to our customers. And it's been amazing. I mean, I've just been so amazed and overwhelmed. The FPUK group, folks on Instagram, which is principally where I do my marketing, folks on Reddit. They've been super nice, super proactive. They've given me so much time. All of my user testing is done by volunteers who raise their hand. And it's almost the other way around. You guys are doing me a favor, but they're like, oh, pick me. I want to do it. And I'm like, wow, I usually have to pay for user testing. So it's super important, and it's super fantastic. And I'm super keen to listen, and I want to innovate, and I want to do things that something that people say in product design. You do the first one for yourself, and then you do the next ones for your customers. So definitely that's something I want to do. And the last point I talked about ad nauseum. So be sustainable.
couple more
So how do we
questions if
make?
you want a breather.
Yeah, sure, no worries.
So any next collaborations in mind? Do you have any that you want to
Yeah,
reveal?
I'm super keen to collaborate. I love to do things like that because I think it brings out loads of interesting ideas. It's things that I haven't thought about. Working with Dennis he's such an amazing guy. He's super smart. He has loads of interesting ideas, and he's incredibly talented. So the short answer is yes. There's nothing that's been locked down yet. Den's super keen to surprisingly still work with me. So I think we're going to do another collab at some point in the future. I know he's in the middle of moving house and stuff like that, or he's planning to. So I think that's kind of on the shelf for now. But I'm absolutely open to ideas. If there's anybody on the call, or someone who you think might be interested in collaborating, whether it's a maker or whether it's someone that does nibs, feeds, housings, anything, surface finishes, machining, yeah, totally up for all of that.
The next question was actually how did you decide on the actual shape and body and the cap of the pen? So I guess the slide is going into that, so you might want to just
Yeah,
talk
no,
through
that's
that.
cool. I can answer that. I mean, I'm a big fan of keeping things super minimal, like just personally. And as I was saying earlier, when you design the first one for yourself, so this is what I think a fountain pen should look like. Um, and what's really, I'm a bit of I'm a bit of an engineering geek and a maths geek. And what's really exciting for me is what are the fewest equations that you can use to describe a three-dimensional object? And that's where I started from. So I've got just one elliptical, an ellipsoid basically. So it's a single equation that describes the elliptical curve or the shape of the pen. And then just the flat plane that we take off that acts as a roll stop. So for me, it was literally okay, I will admit as well. I mean, I guess anyone who's thinking, surely the simplest shape is a cylinder, you fool. And it is. But I mean, come on, cylinders are a bit boring, right? I mean, I don't know. I think they're cool. And I think, maybe the next one should be cylindrical. I take that on board. And part of it was also a little bit of hubris about the engineering challenge of something other than a cylinder, just for the sake of being able to solve a challenge.
Fair enough. And the second part of that question was around, did you go through many designs and prototypes on your pens?
Yeah, so I think to be very honest, as I was saying, the form came very early, so there wasn't a lot of prototyping for the form. But once the form was in place, there was a huge amount of prototyping. Well, I say huge amount, probably 7 or 8 iterations
Mhm.
of just getting some of the functional detail in, particularly the threading, um, uh, the thread pitch, for example, playing with some of the knurling patterns and stuff like that. So yeah, all of that was done. All of that was done with a 3D printed prototypes, which is really super rapid. So again, I don't own a 3D printer, but there's a shop down the road that does it for me. And you just send something over, just log into their interface, send something over, a design over, and it's usually 24 hours. They say 48. It's 5 miles on the road. I ride my bicycle there, pick it up, and I'm able to do like 2 prototypes. I was at that time, I think, so these 7 or 8 prototypes I did maybe in 4 weeks. So it was super fast, like 2 a week.
Right. Then two suggestions for, I guess, pen makers and who you can work with. One was Gravitas from Jim, and obviously Andrew, a pen friend, who said he would love to do some artwork with on your pens with for CNC engraving.
That's amazing, Andrew. So both of those are amazing, Andrew. I'd love to take you up on that. I think that's a super interesting idea, and yes,
I'm intrigued too what that would look like.
we can talk offline about that. But yes, I think with Gravitas, so I speak to Ben on and off, not very regularly, but maybe I've spoken to him 4 or 5 times in the last 6 months. I don't know where. I think we kind of do very similar things, to be honest, in terms of the machining. At least the end product is similar. I think his approach to how he does it is very different than I do, and I think um, he's much more focused on the surface finish, and I think my understanding is he spends a lot of his time on these beautiful surface finishes, and he spends a lot of time thinking about like the Skittles pen and so on. And for me, my approach is very, very different. My approach is about the functional, the object, the ink delivery system, and stuff like that. So I'm not entirely sure where the opportunity is to collaborate, but I mean, yeah, Ben seems like a super nice guy. I'd love to I'd love to figure out if there's a way that we can work together. Okay.
Yeah.
So we kind of covered this already, but this is kind of what it looks like. I don't know if you can see my mouse cursor. If you can, it's this little colorful object at the top was the broad form that I started with. That's literally what I started with. And then on the bottom right here is a kind of almost complete render of maybe towards the end of the prototyping process. And then again, very interesting learning experience experience for me when I started speaking to the CNC guys, quite foolish, well, not foolishly, but naively. I sent them, 3D files, and I was like, "Here's this object. I need to make it." And they were like, "What the hell is this?" So I had to, I had to actually go into, and fair enough, right? I had to actually go into the detail to actually do two-dimensional drawings, which look like this, engineering drawings, to specify, lots of detail that it's not entirely obvious in a 3D model. Things like, how you want your thread pitch, where you want your machining, the tool paths for your machining, and so on and so forth. So that's kind of broadly speaking the process. As I was explaining, start by thinking about the form of the object, the functionality. The form follows from that function. Do some rough sketches, do 3D models, and then produce engineering drawings with all of the specification for the functional parts. And then these last two things, the machining instructions and the tool path programming, were completely alien to me. I thought, okay, I've done the drawings for you guys, off you go. But the truth of the matter is, what kind of machine are you using to actually make this object? You're starting with a solid rod of aluminium, and then you've got to drill the rod, you've got to shape it, you've got to do the plane. How do you get the plane on our design sits across three components? So how do you make sure that when those components are threaded together, the plane lines up? So um, the operation to take the material off for the plane needs to be indexed or timed to the operation for cutting the threads on the inside of the cap or the inside of the barrel, for example, and the grip section, the exposed brass bit of the grip section as well. And so some of those things which I didn't really think about, I was like, here's the design, go and make it. And a couple of the CNC guys came back to me and said, we can't make this. We have to make the entire object, assemble the components together into the entire assembly, put it into some kind of a jig, and then actually slice the material off. And I was like, that's insane. You can't do this one by one. What if I want to make 200? Or, what if I want to take the parts apart and send it to somebody to anodize the parts and then bring them back, and I'm sitting there trying to sort of do permutations and combinations to figure out which things match. So solving some of those problems was really interesting, and completely, I went in completely naively, not knowing. And then I did a little bit of research. I had to go back and read some engineering textbooks, and I was like, okay, there is a way to index this or to time the cutting of the threads, and can we do it in the same operation? And then you had to use a special type of machine, a special type of CNC lathe. It's called a Swiss lathe. And they were invented many years ago, before CNC machines, for manufacture of chronometers and watches, where you need to have exactly these kind of tool parts and machining for escapement mechanisms for watches and stuff like that. So somebody had solved the machining problem already, turns out, and there are citizen Swiss CNC lathes that are people run those shops very much in the UK and around the world. So I went looking for some of those guys and started to have a conversation with them about how they could do it. And it was like, oh yeah, that's super trivial. You've only got three components in your assembly. Pff, we can make that all day long. And starting to work with them to understand how to make that. How to achieve. Um, uh, how to achieve this with the production process rather than doing it one at a time. And then I just wanted to show you, this is kind of how we start these rods. There's brass and aluminum that we're using at the moment in the pens. They're actually about 16 millimeters-ish in diameter, and then they get ground down very, very precisely to an exact 15 mil diameter rod. And these rods are super long. So we buy them in 3,000 millimeters, so 3 meters long, basically. massively long bars like that, and they get fed into the machine. And these Swiss lathes, I've got a video to show you later. They have a chuck that holds on to the material and slowly feeds the material out. So if you think about this as the bar, the bar sort of emerges from the chuck, and the cutting tool or whatever it is able to operate around that, or the bar is able to be held stationary and the cutting tool can move, or the other way around. And what's really cool about that is, because you're doing it that way and you're feeding the material out, you don't have problems with deflection. Because what tends to happen otherwise is, when you have a cutting tool and you're just holding this material here, you get some kind of deflection like this, which causes significant issues with tolerance. So you then can't do, for example, some of these timing and indexing operations that we wanted to do with the flats. So that's the material comes from France. It's the closest I could find. Turns out nobody does brass and aluminum to this in this shape, in this spec, in the UK. This was also an interesting learning experience for me, because there's things about how pure is the bulk of the material, how consistent is it. And you get, you can obviously source material cheaper if you want to, but then you run the risk of having issues with the material consistency. And those, initially, when we tried to do a few tests, and found that there's issues with the material. So there was a little bit of work that needed to be done to actually find consistency in the material as well. And this is a really good example of something that if you're kind of outsourcing all of this and sending your stuff off somewhere far away to make, you don't even realize this, because you're not confronted with this problem, and you get a finished part, and sometimes you don't have a full appreciation or awareness about the bulk properties of that and how consistent they are. You think in your mind, I asked for aluminium, they gave me aluminium. But actually, it's an aluminum alloy. It's called 6082 aluminum. It has some chromium in it, and a couple of other magnesium and stuff like that. And it's designed. It has to be, the structure has to be absolutely precise to get the precise machining. And if you're involved and hands-on, you're able to sort of control that, or exercise some kind of preference, rather than having something just given to you. This is kind of what I was talking about. So you see the material being held here, and we've just taken the flat plane off, and we're just finishing off. This is one of the barrels on the left hand side here, and I've got a short video to show you that hopefully will play, which shows you the chuck coming in, and the tool basically boring or drilling out the aluminum rod to make. I want to say this is one of the caps. Yeah. So I spoke about a lot of this. So making sure that the raw material, the rods, are ground down to that 15 mil nominal diameter. Because when you buy the rods and they come in, you specify 16 mil, or rather the supplier specifies 16 mil, but they're not exactly 16 mil throughout. There's maybe 100 microns plus or minus, something like that. So they have to be ground down precisely. So that's the first operation that we do. And then the next operation, so these rods are now about 3,000 mil long, and they've been ground down to this 15 mil diameter. And then they go into the machine, into the CNC. And then each component gets shaped, and then it's sliced off. One done, next one, next one, next one. And you can literally make, I don't know, like, it takes maybe a few minutes, maybe less than a few minutes to make each component. So it just runs, once you've got it running, it just runs all day long. And what's really interesting, as I was saying earlier, going from an engineering drawing to a machined product, is understanding what are the tool paths. So what tools are you going to use? What path is that tool going to follow? The idea there is you want to minimize the amount of time on the machine, because effectively the cost of the part is pretty much, I mean, raw material, of course, but beyond that, it's pretty much the time on the machine, because the machines are so expensive that you've got to try and minimize time, and minimize the number of operations, and certainly minimize manual intervention where somebody has to take a part out and put it somewhere else, or turn something up, or change a tool around, or something like that. So a lot of optimization that I've been doing between batches. I mean, as a consumer, you might have seen one of the pens with our first batch that we did, and then which was black, and then there was some blue special edition, and then with the raw series batch that we did, And it looks exactly the same. It's exactly identical, but the manufacturing process was redesigned from the ground up to optimize the tool paths and to make sure that we can machine everything in a single operation. And there's still a lot of work to do. So over this period, I was mentioning earlier on the call, I'm actually working with the guys in the machine shop to try and further optimize this, because I want to sort of understand if I'm going, right now I'm making batches of 200, 300. If I want to go to make a batch of 1,000 or 2,000, what does that mean? Being able to shave off 10, 12, 15% is very, very significant in terms of machining time. Oops. And something that's really cool that I wanted to talk about as well. Once these pieces come out of the machine, the question is, have they been machined correctly? And everything is computer controlled. In theory, you would imagine, of course, they're machined correctly. But there's all sorts of random things. Even buying the best raw material or whatever, you still have, the material isn't 100% identical and accurate. You have issues with tools, temperature in the workshop when you worked that day, the humidity in the air, stuff like that. There's some burrs that are left over, a little bit of material that was taken out that got stuck in thread, and then the tool went through that, and so there's a piece of the thread that's imperfect or whatever. So there needs to be some kind of quality assurance process that you go through. And what's really cool, so my CNC guy uses these awesome machines, and I wanted to just share a video. So the idea is that you have a camera, just a standard video camera, and then you have this flat bed, and you put the component that you want to test on the bed, and the video camera is able to take a video of this component. It doesn't matter how you orient it, you put it this way, that way, vertically, it doesn't really matter. As long as the camera can see it, it's on the bed. And it compares that to, it has a map of about, I think, 400 points that it knows from the engineering drawing from the 3D. And it's able to tell you, is this part accurate or not? That's it. So you just put the part there, it goes green, you take the part off, put the part there, it goes green, you take the part off, put the part there, it goes red, you say, shit, that one goes in the throwaway bin. And it's super cool. So here's a little video of this thing actually in action. So we've got the part on the surface. And what you see here is it's basically scanning and analyzing the part. It's just a camera that's taking a picture. And it says, okay, everything's good. I'm happy with this one. Thank you very much. And off you go. Ugh. So that's the story of making the pen. And what's actually more interesting to me, sorry, I've actually spoken for really long, and we've almost come to the end of this, is the ink delivery system. And one of the things I was amazed about was there's just basically, from an OEM perspective, there's 2, 3 maybe big manufacturers that make fountain pen nibs, and there's so much going on in the ink delivery system. And I think you guys probably are quite sensitized to this, but there's ink flowing out of the cartridge or the cartridge converter or whatever it is, but actually that fluid flow is bidirectional, because you've got to get something in there to replace that ink, otherwise there'll be a vacuum and you won't have any ink anymore. So there's actually air flowing in the opposite direction. There's a whole bunch of different forces that are acting for you to have the line on the paper. There's the writing pressure that you put down, there's the fluid pressure, there's gravity, there's capillary action, which is impacted in turn by the type of paper and the type of ink. And there's all these external variables that I was talking about. And we haven't even got into flex yet. So it's actually non-trivial, and it's actually quite an amazing innovation from the 19th century to think about how an actual sort of fountain pen is designed and works. And this was my point about very few OEM options were available. There's no clear sort of standard across them. There's Jovo and Bock and pretty much maybe Schmidt, and pretty much that's it. And I was surprised at that. And I was surprised that there's you have beautiful pens, fantastic pens, and I sometimes see this on people's review sites on YouTube, and they're doing a writing sample, and I'm like, that's another Jovo nib, man. Like, really? You don't even need to test the writing sample. It is what it is. It's Jovo nib, and that really bothered me massively. And it's the same story with the feeds. I started out using these Ebonite feeds, and people who know me, it's my favorite subject to rant about. It's absolutely ridiculous. It's a deprecated engineering material. It hasn't been used or specified in any engineering use since the 1930s. And I think pretty much fountain pens, and I think somebody was telling me smoking pipes. um, I don't know how large that market is, but probably worth looking into, is pretty much the only place that this material is still being used. And I mean, as a surface finish material, if you make a pen out of ebonite and you say, aesthetically I like it or ergonomically I like it, fair enough. But precision machining a feed, it's insane. The bulk properties of the material are not consistent. It's really, really hard to machine. You have to use, so basically the guys who machine these feeds, they have to use a whole bunch of oil to keep the cutting tools cool, and to keep the part cool, the bulk material cool. Oil gets all over into the channel and stuff. It's really, really hard to clean. So you get these things and you've essentially got to pressure wash them with soapy water to make them function. It's insane. And then at the end of all of that, you need to heat set it and you send it out to customers. You tell them, listen, you've bought this pen, it's yours, but don't disassemble it, because then bad things will happen. It just seems crazy. And so what's your option? Okay, you can buy some injection molded plastic. It's super cheap. It's very precise. But sorry, it doesn't like ink. It's it has a hydrophobic surface. So if you can try this experiment with the feed at home, you just put a little drop of ink and it just pulls up because of surface tension into a little sphere, which is ridiculous. You want literally exactly the opposite for an ink delivery system. And so this was driving me crazy, and this became my sort of singular obsession in July and August. And it just seemed like the absolutely wrong thing to do. And I was, again, when you're doing 10 or 20 pens, it's fine to set up the ebonite, but trying to set up ebonite nib units for 200 pens, it's not fun. So that's what led me to, again, from an engineering perspective, I'm like, surely there's polymers that we can use to manufacture in at scale, um, that have the hydrophilic, the water loving properties that we want, so that you don't have ink just pooling up, but it allows for fantastic ink flow. And so I set about doing this. And again, at the time I was told, that's a bit silly and there isn't a market in it. And I was like, it's okay, it's just me doing it. Let's see let's see where I get to. And I'm super happy. It's reasonably consistent. The tolerances on the polymer feeds that we make are still not quite where I'd like them. So they're around sort of 90 microns, something like that. So just under zero point 0.1 of a mil. And that might sound amazing, but it's not really great, particularly for something like a feed, which needs to be, which is one component that goes into an assembly that needs to be quite precise. So I still have a lot of problems with this, in the sense there's a significant amount of rejection. So what I'm doing is I'm doing a standard core, and then I'm using laser sintering to build up a surface layer. And that surface layer is built up from a polymer that's hydrophilic. But that's the laser sintering process itself doesn't allow for any better precision, because essentially you have a bed of very finely ground polymer, and you're using the laser to kind of melt or sinter that polymer and coat this material. And when that polymer melts or sinters, it flows like a fluid. And that fluid flow is dependent on the ambient temperature, the humidity, and a whole bunch of different things that it's harder to make these feeds in winter, for example, because where in the machine shop where we make them, um, the temperature fluctuates a lot, and the heaters kick in, and when that happens, it messes up the tolerances. So mm, essentially, feeds that were machined on Friday are the most stable, because the heaters have been on consistently throughout the week, and then they get turned off on the weekend, and the feeds that we make on Mondays are not so good. So this is another thing that I need to redesign from the ground up, and hopefully and probably from an end user perspective, it's going to look the same. But it's one of these things. It's kind of January schedule to try and find totally different manufacturing process with the same materials. And that's what it looks like when it works. So this is from one of the reviewers who tested out our pen. I was really happy with that, just to see that. There's challenges with nibs as well. I'm running out of time, so I'm gonna stop. Um, what do I want to do next? I think one of the things with the nibs that we're doing at the moment is I've intentionally wanted to design something that's usable for everyday writing as well. And people who have any experience with flex nibs, probably you see these really soft nibs that are really, really hard to use on a day-to-day basis or without a fair amount of practice or experience. But I think with our pens, with our nibs, you can just take it out and use it to make notes or whatever. And if you want to put some pressure down and flex, or get some kind of detail in your some kind of flair or flavor in your handwriting, you can certainly do that. But I want to do super soft, and my hypothesis at the moment is that probably 80 or 90% of how soft a nib is down to the geometry, the shape and thickness of the material of the nib and stuff like that, and maybe 10 or 20% is down to the material. So again, sort of fighting this dogma, like there was this dogma about ebonite that I was not sold on, and there's also this dogma about gold that I'm not super sold on. I mean, 100%, it's much softer than stainless steel. There's no arguing with that. But I think by tuning the geometry of the stainless steel, you can achieve a very, very comparable softness and springiness and bounce back. So that's my hypothesis that I want to test. That's another thing that's on the list for January. The other thing that I've got really into, and this kind of came as a side effect of the feed, the feed design project, is guys who do optical instrument making, and those are the guys. So the moment you start talking to people and you say, look, I want to talk about precision down to 20 microns or 30 microns. That's pretty much one of the sort of large scale industries that talks about manufacturing techniques with those kind of precisions. And I think that's kind of what we need for feeds. I think that's kind of what we need for nibs as well. So imagine a world where you can specify exactly the kind of grind that you want on your nib, and there's a machine that just does the grind for you. And at the moment, of course, you go to Nibmeister, and this is someone with 20 or 30 years of experience who pretty much by feel can tell you, how hard to grind the nib, what kind of rough, the degree of roughness of the surface against which you're grinding it, and getting that absolutely perfect feel for you. But I mean, in theory, there's no reason why something like that can't be done um, in using some kind of automation. So that's something that I want to explore. I really want to explore some engineering polymers. I see with great sort of envy people machining pens out of Altim and Delrin and Peaks and stuff like that. And I think that's super exciting as well, apart from metals. And I think, there's lots of people doing surface finishes, but I don't think there's too many people who are thinking about surface finishes from a very sort of core engineering perspective. And that's something I want to play with. I've been talking to some of the anodizers, and a lot of them describe this exact same kind of analog world where, oh, it's kind of a little bit of an art process, getting this exact blue or getting this exact green. And I'm like, okay, great, but why? So I think there's some opportunity to play there as well. And then to the question that somebody was asking, I think, the second pen, the next object that I design probably needs to be much more user led and less, what does Sunil think a fountain pen looks like? And my final sort of, where I want to end up with this business is to make everything on demand. You go to the website, you order a pen, and we literally basically print a pen for you, just super locally. Everything, the nib, the feed, everything. And where the technology exists today, it's just not commercially viable. The cost of additive manufacturing is dropping by 50% every 18 months or so. So there's no reason why that can't happen reasonably medium term, not far into the future, but I'm talking 2-3 years rather than 10, 20 years. And my final thing, is I really think that stuff should be open, and one of the things I want to do is I want to open source everything that I'm doing. And I mean, it's a business. I still want to make money off it, but for non-commercial use, design files to 3D print the pen yourself if you like, information about how, as I perfect, how we make the feeds, maybe if we can make nibs as well, how we make the nibs, and just put it out there and let people. I mean, certainly for the object itself, the pen, it's super trivial to, if even if you don't have a 3D printer, there's loads of services that'll print something for you, 15, 20 pounds. You can have something you don't like black, you want to make it green, you want to put your name on it, off you go. So that's something that I want to do reasonably short term in the next 3 to 6 months. Just put everything out there open source, and for non-commercial use, let people play with them, let them build on it, modify it, whatever. I'm going to stop now. I've massively run over time, and I wanted to talk about Flex as well. But I don't know, Purva, if there's any more questions for me. And I'm sorry if I've bored you guys.
I think if we were bored, there wouldn't be the same number of participants that we started with, Sunil. So I
I
think
can
it
only
was
see
really
my
good.
own I can only see my own screen, so I don't know if there's only you and me, Apurva.
No, no. Everyone's enjoying the talk. I think it's just the comments is like really interested in the talk. I think I speak for everyone. I think everyone would like to see this getting started with Flex. There's one more question though before we move on to that. Callie's asking, have you found any particular paper to be the best with your pens, standard nib versus calligraphy?
I think, I mean, the short answer is no. I think that's a very personal preference.
Yeah,
So my
I
personal
agree.
preference is Clairefontaine. I like smoother papers. So I really pretty much for all my testing and if I reach for a paper to write something, I would reach for Clairefontaine. And I usually use I'll show you in a minute, but I usually use this 90 GSM fairly smooth hot pressed paper. And I think for the calligraphy nib, because it's untipped, you want to try and write on something smooth. Having said that, you don't have to. I mean, again, Rob, the craft paper envelopes, which are not exactly super smooth. I've been using the calligraphy nib, my calligraphy nib, to write those out. So I've literally been doing the opposite of what I would recommend. I'm using a heavily pigmented ink with a calligraphy nib on a super rough surface. It's fine. You just be a little bit careful and make sure you clean the pen afterwards and be a bit mindful of your upstrokes so that you don't get the nib snagged on any textured bits of the paper. But short answer, Clairefontaine, personal preference.
I think in that answer, there were about 20 comments saying continue with the flex, and that was an excellent presentation. So continue. I don't think there's any issue with the recording, is there, Andrew? I think we can continue.
Okay, let me just figure out how I okay, let me stop the screen share first. Yeah, okay, excellent. And then I need to change my camera view. Yep. Okay, so you should be able to see my desk now
Yep, can see that.
with a stack of Clairefontaine paper. Claire. Yeah, so I basically I was talking about my, where I started with Flex, and I wanted to show you, hopefully that's in focus, but essentially what this is it's a pointed pen nib, and it looks like this. And it's by a British brand called Leonard, and it's called the Leonard 256. But they also, other nibs are available, of course. It's made out of steel, so it's not stainless steel. Sorry. And it's completely untipped. And it's super, super soft and super, super thin. So I don't know if you can see this if the camera is picking it up, but I mean, it's like I'm holding the tines apart at maybe 2+ millimeters at the moment. It's super, super soft. Of course, it's not stainless steel, so it's going to get corroded, particularly in an environment with ink. But this is where I got started. So that's the pointed pen nib, and the way that they're meant to be used is they go into a nib holder. I should have actually had one with me, but I don't on my desk at the moment. But it's literally just made out of wood or whatever. And then you dip this in your ink bottle, and off you go. Um, but of course, it so happens that these Leonard 256s happen to have the perfect radius to fit this feed, which is a bog standard plastic feed that fits into Yovo nib units. And it's also the kind of thing that you'd find in a lot of low cost but reasonably well made pens, fountain pens. So for example, I'm thinking about the Jinhaos, the X750, X450, and so on. Um, I've got this with the Yovo threaded nib unit here. I just have that just to show you. And this is transparent, so that's quite helpful because you can see what's happening. So, you literally just put the nib and feed together. These Yovo nib units, probably, I don't know if you can see that, but they're kind of indexed or slotted here. So they can only orient into the into the housing in one way, in one orientation. And you literally just pop this guy in there. Um, it's transparent, so you can see how far that goes, and you can see what that looks like. And I'm going to try this. I don't know if it's going to work or not, but just for fun. I hope it's probably, yeah, sod's law, it won't work. But standard section, Yovo threaded. So that should work. Just pop this guy in a little bit of ink to get him started. Since July, I've used 3 bottles, 380 ml bottles of this, which is my favorite blue. It's not working. Maybe just push some. So I'm just pushing, like forcing some ink through the feed. It does work, I promise. Come on. Ah, here we go. No.
Someone's just asking what ink is that? I think the screen was a bit blurry.
That's diamine Mediterranean blue. So this thing is refusing to cooperate today, which is super annoying. Come on, man.
Murphy's Law.
Exactly that. But here's how it's supposed to work. I'm literally using it as a dip pen now. But maybe it just needs a little bit of fiddling with it. But I guess what I wanted to say with this was you could quite easily just use this in. So here's a pretty bog standard Jinhao 750 pen. So it's exactly the same feed. So quite happily you could just pull this guy. You could quite happily just pull this guy out. That's a super inky nib. And just pop that into the Jinhao, no problem. And same thing, this thing doesn't have a housing, but it is indexed. So you've just got to make sure the flat bits line up, and a bit of force needed to put that in. And there you go. So that should, I mean, I don't know why it's misbehaving today. Let's give it a bit of a dip, see if we can get it to behave itself. There we go. Yeah, definitely Murphy's Law at play. But that's kind of how I got started with flex nib fountain pens. So it was very much about just finding nibs that fit, sticking them in. And what's going to happen over time is this guy, because he's exposed to, or the undersurface of this nib is exposed to the ink, it's going to start rusting, corroding essentially. So it's probably a good idea to have a few, if you're using one of these Jinhaos, it's probably a good idea to have a few of these plastic feeds, because it does get quite challenging to take the nib and the feed out of the body of the pen once it's all jammed up. So sometimes you have to just kind of go at it with a pair of pliers and just rip it out. But the good news is that you can buy these nibs for, I think like you get a 10 pack of them for maybe like 12 pounds or 11 pounds. So it's like £1 a pop. And it's the same story with these plastic feeds off of eBay or something like that. You can get a whole bunch of these plastic feeds for like pennies, maybe 50p or £1 each. So it's fairly trivial. And I mean, your mileage may vary on the gin house depending on where you buy them, but let's say £5. So all I'm trying to say is if you wanted to get started with flex pens, it's not perfect, um, but you could get started for 15, 20 quid, like literally the cost of a Lamy Safari or something like that. And it's super rewarding. And you work your way up from there. You start to find that the feed doesn't quite keep up. So sometimes with these gin house, you find yourself just kind of having to just prime the feed a little bit, just force a little bit of ink through using the cartridge converter. um, and maybe you have to do that every half a page or so, but that's not too bad. And that's kind of where I started from, just with something like that. And I thought it might be worth, let's get all this stuff out of the way, might be worth also showing you. Hopefully this behaves itself. So that's one of the pens that we make. So this one is from the raw series. So it's raw unanodized aluminum, and it's a fine tipped flex nib. Sorry, and with the polymer feed as well. So I mean that's kind of pushing it quite a bit. Like usually when I not doing a demo and I'd write a lot slower, for example. Something like that. So I mean the only thing I'd say, in terms of using these, and with our nibs, I mean they're fairly, so that's just how you'd write sort of on a day-to-day basis. So they're super happy. You do have to put a fair bit of force down. So if you're used to using some of the gold vintage flex nibs, or you're used to using something that's been sort of custom, with the custom geometry, from Kirk Spear or Stylus Suite or something like that, those are so much softer. And sort of almost intentionally, at least at this point in time, um, these aren't all that soft. Um, but I think it's a really nice balance. And then just to show you really quickly as well, so that's the untipped calligraphy nib. So the difference between these two, I'll show you side by side. So the one on the right is the fine flex nib, and it has it has some standard tipping on it. And this one it's stainless steel, so it's not going to corrode or rust or anything like that. But it has absolutely no tipping on it. And it's much, much scratchier and needs much, much smoother paper. But it's much, much softer, and it produces a much thinner hairline. And of course, trying to go fast because I guess it's a bit boring to watch someone write. But it's, I mean, for me, it's super cathartic, just the flow and the line on the paper. You watch the ink pool as it moves away from the nib. It just, yeah, I mean, it's a joy. It really is. I mean, just any flex nib, it's just an absolute joy to use. So it's quite, it's a bit of a rabbit hole, I think. So that's the kind of health warning or whatever. I don't know if there's any questions or anything else.
No questions in the chat yet, but you guys are welcome to
I wanted
unmute
to
yourself.
just ask one question about your nibs, if I could. Hey, it's Jim here.
Hey, Jim.
I'm absolutely loving your nibs, but I'm impressed by how much line variation you're getting off your fine-tipped one. How much pressure does one use them? Is there a working period? Do they soften up a bit over time? Those kind of things, or are they pretty much as good as they're going to be straight out the box?
They will that's a good question. They will soften up a little over time, not a lot. And I am putting a fair bit of pressure down. So I am putting I'm not sure how best I can quantify it for you. 300 grams of pressure at 45 degrees, Jim.
Perfect.
Circa. I mean, I'm not making that up.
Can you do that in newtons? Could I have that in newtons, please?
Yeah, well, standard gravity, assuming you're on the Earth's surface, is 9.8 meters per second square. So I'll leave that for you as an exercise. but
that was brilliant.
I think less pressure needed on the surface of the moon. But no, I mean, there's a fair, it's not to be flippant, but there is a fair amount of pressure. And I mean, they're fairly sturdy. They're quite thick. So compared to, let me bring this guy, where is he?
So let me just add my opinion here. I've been using a Sonos tipped fine flex nib, and is easier to flex than a nodeless A hub, for example, out of the box. And so you take that around like half of the pressure that you would use on the nodeless A hub.
Yeah, I mean, so coming back to this guy, which is a dip pen nib, I mean, he's much, much, much softer. So it's a lot less pressure here. But, it's going to be very hard to spring these nibs, Jim. That's what I'd say. I mean, you really can be a little bit more aggressive at them than you might first think. So, I mean,
so much. I think that's probably the key to it. Is certainly with the untipped calligraphy flex, I get great line variation. But yeah, with that fine flex one, I think I've probably just been working it too gently. So I'm going to really go for it with that 2.94 newtons, I think.
Yeah, give it a bit of a, yeah. I mean, what's the worst that'll happen? You'll destroy the nib. You'll send me a message, and I'll post you another one.
Sunil, can I ask?
And that's why we love you.
Sunil, I've had a couple of your nib units, but I have to keep forcing the ink through the nib by turning the converter.
Yeah. Is that are you what's the feed that you're using with those?
I've got your ebonite feeds.
Okay. Yeah, I mean,
look, I just can't keep the flow. I have to keep forcing it through, and I have tried different inks, including the Compeki that was recommended, and a nice wet private reserve. Yeah.
No, I think that's a fair point, Ross. I think sort of my take on it is that shouldn't be the case. And maybe it needs looking at. I'm happy if you want to send the nib units back to me. I can take a look.
Could it be because the converter easily turns when it's fixed in? It's not really tight. Could it be air that's getting in?
Yeah, definitely. I mean, one of the things with railroading particularly is it's much more about airflow than it is about ink flow. So, I mean, look, for example, I've got this guy here, and it's a fair amount of force to get him out. It's quite
turns. My converter turns in the unit.
No, it shouldn't.
Try pushing it in. Just try apply a bit more pressure.
I've tried that. I've even tried putting other ones in, and they all will turn quite easily, even when they're pushed in hard.
So, I mean, it definitely sounds like that's an issue. And one possible, again, my sort of frustration with ebonite always is, it could be just the diameter of the housing, the ebonite housing. It's nothing to do with the feed or the nib. And it might just be as simple as, swapping the housings. Well, I say as simple as, but yeah.
I think, Hayes, you had your hand up. Would you like to go next? And then we can go to Bernardo.
I think Bernardo had his hand up first.
Okay, Bernardo, you first.
Thank you. So no, sorry. That's Thor. Angry with this tablet. Sorry. Your titanium and gold nibs, you're gonna make them available separately as well, and your regular nibs too. Like you buy only the nib units with your polymer feed.
Yeah, so I mean, definitely the gold nibs, we've made them available. Of course, they're out of stock at the moment. It's a bit of a tough one for doing that with the stainless steel nibs. And, just very candidly, from a commercial perspective, I want to be in the business of selling fountain pens and not so much nib units just yet. And it's partially that, and partially it's one of the challenges that I am having at the moment is producing the polymer feeds at scale to the kind of quality that I'm happy with. So there's still a fair amount of rejection that's happening at the QA stage. So effectively, I'm kind of in triage mode where I'm like, the thing that's holding me back in terms of volume is the feed. And so I'd much rather be selling the feeds in pens rather than selling them as standalone nib units, just purely from a commercial perspective. But once I'm hopefully in a position where I've solved that problem with the feeds, yes, super happy to do it. Does that answer your question?
Yes, thank you. I replied on the chat.
Oh, sorry, I should probably bring the chat up.
I've just got one quick question. Do you think that the ink delivery system has a lot to do with the actual feed of ink into the actual, the ink into the feed, which then has obviously a performance difference on the actual nib itself? I have heard some people say that having a larger aperture for the ink to actually get into the feed provides a slightly better flow.
That's a good question. I think the short answer is yes, 100% it would. I think the slightly longer answer is there's two things that are happening. There's ink flowing through the feed and nib to the paper, and then there's air flowing back to take the place of that ink in the whatever that sealed delivery system is, the barrel of the pen, if it's an eyedropper or a cartridge converter or whatever. And I think both these things need to happen correctly for you to get uninterrupted ink flow. And I find from whatever little experimentation and research that I've done, that it's as much, in fact, if not slightly more, about how the air gets back in. So the cross-sectional area of that diameter, the opening, the aperture, is as much about getting the air back in as it is about getting the ink out. I think one of the challenges that you face, and I tried some experiments here as well with these eyedroppers, where typically you have a much larger aperture, is temperature variations, because air, obviously is much more sensitive to temperature variations in terms of its expansion, and so you get very inconsistent ink flow, a lot of burping. You don't get fine, your fine lines aren't as fine. So it is, for me, the conscious decision to use, for example, the international standard cartridge converters was about having precise control over the lines. And again, this is a personal preference thing driving a design decision. But for me, the joy of the flex is as much about the hairline as it is about how fat or wide or juicy you can make the swell. So what I mean by that is I much more enjoy going from 0.2 to 0.9 than I would going from 0.5 to 2.0 millimeters in terms of the line variation. And I think that at the finer end of that, at the 0.2 end, at the really hairline, extra fine, it's all about controlling the ink flow.
Oh, I agree 100% on that. And I think that is something which is quite poignant with a lot of modern flex nibs, is that the ink delivery is so generous that you just don't get those hairlines. And I think that's what you really do highlight on the fact that I think when you start looking at those dip pens, that is really what I think people just really sort of gush over. It is that sort of width from that really finite hairline to these almost like the slightly broader line. It doesn't really matter how broad the line is. It's that hairline which is really important.
Yeah, I mean, again, look, I agree with you completely, but I also do acknowledge it is very much a personal preference.
Yeah. Hayes, I think you had a question.
Yes, I did. Yeah, I actually have two questions. One, I'm a dip pen user myself as well as fountain pen user. I know you mentioned that Lenart nibs are the like go-to ones that you went to. I've also got some Perry nibs. Do you have a specific one that you would recommend as like the go-to one? Because my favorite nib recently got damaged, and I'm looking for a good replacement.
So fair enough. I mean, personally, I like the Lenart 256. It's very similar to in its performance to the Zebra Gs and the various G nibs that you can get. So it's kind of an all-round happy nib for a dip pen. What's particularly nice about the Lenart, as I was desperately trying to show but failing, was that you can its radius, so just by coincidence, happens to match that of a Yovo number 6 feed. So you can just stick it into any Yovo number 6 fountain pen, like a Jinhao or whatever, and off you go. Yeah. The other thing is, I would say the Lenart principle. It's much finer. It requires a lot more. It requires you to be a lot more gentle. It's super fun to use. You need super smooth paper.
The principle is the best one.
It's fantastic. It's something else. It's
You
really
tried the blue
something
pumpkin
else.
as well.
Say that again. Sorry.
The blue pumpkin. You tried it.
I have tried the blue pumpkin, which is also very nice.
That's crazy flex.
Yeah, super soft. With these nibs, you know what? First of all, it's made out of steel, not stainless steel. What I mean is mild steel. So it's the material itself is so much softer than stainless steel, and they're machined much like maybe 2.5 times thinner than fountain pen nibs.
Yeah.
So there's just less bulk to move to flex, and it's just much springier and softer as a material, mild steel by default. So it's just, I mean, it's an absolute joy. The flip side or the downside of it obviously is that it oxidizes very easily. And I mean, you'll be amazed at what a wide spectrum of pH you find in various ink formulations, depending on colors and various other things. I mean, going all the way from super acidic inks that are like, pH 2, I mean, all the way up to really alkaline inks that are, 9, 10, 11. So, the poor nib stands no chance, in a week it's gone.
Yeah, that's kind of what I've discovered with the nib that was breaking. It is starting to just corrode to the point where I can't use it, and I'm going to have to replace it. So thank you for all those recommendations. I've written them all down. The other question I had was, how well do you think that your feeds will work with shimmer inks? One of the things I love about flex nibs is using shimmers and being able to get that real good shimmer in there. So how well do you think they work together?
Yeah, I mean, look, the short answer is less well than using a well-behaved happy ink with no particulates in it. But they work just fine. I mean, on my Instagram, I have lots of pictures of the last 15 or so days where I've been using diamine golden sands quite extensively, especially for this time of year. And then I also use Geaband's Kyanite du Nepal, if I'm saying that right, which is blue. It's a fantastic blue, and it has a silver shimmer. Yeah, it's a beautiful ink. So it's perfectly fine. There's no reason why you shouldn't use shimmers or any of the other inks like that. The only thing I would say is clean your pen afterwards.
Yeah. Yeah, thank you very much. That answers all my questions. Thank you.
I think Dennis, you said in chat that you had a question.
It's already been answered.
Actually, suggestion, Hayes, with the shimmer inks, roll your pen before you use it. So when you have it sitting and you've shimmered it, and if you're using it the next day, roll it, it gets the ink flowing again.
Definitely. I mean, I was just writing those cards, the addressing
And
the
wear
alpha
condoms when
cards.
you use shimmer inks because they are higher piece of fountain pens.
They're really not that bad, but okay.
Yeah, I mean, look, my opinion on this is everyone has a different point of view on inks, and there's so many inks. And as someone who makes fountain pens, you shouldn't be telling people you can use my fountain pen, but only use it with these 3 inks and only on this one kind of paper. Bullshit, if Hayes wants to use shimmer inks, by all means, you should be able to. And okay, tell me what I should do to use it right, or tell me that it won't work, and then I won't use it.
Certain inks will work better, but there's no harm in using shimmer inks. They don't damage the pen in any way. They might clog the feed a little bit. You might have to it, but
yeah, you do. Yeah, I think basically once
it's just hard to clean and I'm messing around.
Yeah, you have to take the whole thing. You have to take the whole thing apart, and literally wash the feed, wash the housing, wash the undersurface of the nib. With the diatramentis, I literally just cleaned my pen maybe a couple of hours before this call started. And it was a bloody nightmare. I pulled everything apart, and the inside, the undersurface of the nib was coated in the diatramentis white pigment. And I had to take it out scrape it out with an earbud. So, but it's beautiful, man. When you write with white ink, it just looks fantastic. I can't stop using it.
I'm a hardcore fan of shimmer ink, so I'm all about the getting glitter on a piece of paper because the flex nib shows off the shimmer very well. Any more questions?
Not a question, an observation. We sorry, because it's a repeat of something I kind of mentioned yesterday, but it'd be good to get your thoughts on it, Sunil. A lot of sort of nibs nowadays have got all this sort of engraving and stuff sort of all over, especially in front of the breather hole where the tines should move freely. And it struck me that just like corrugated steel, it's got this shape to it to make it more rigid. And if these engravings are done just aesthetically without taking into account the structural difference it's going to make to sort of movement, surely that's a detrimental thing. I mean, is this something you've looked into, or is this something you kind of have any thoughts on? Because when I keep looking at these old sort of, Waterman antique nibs, I've never used one that, people rave about. They're very simple and kind of, as the nib comes to the point, sort of ahead of the breather hole, there's usually nothing. There's kind of a Waterman's behind the breather hole, and maybe one or two kind of little flourishy things. But
yeah, I mean, it's a very interesting observation, first of all, and I will say honestly, I haven't thought about it very carefully before now. I will say certainly when it comes to laser engraving, I mean, we're taking off so very little material. I mean, the depth that we're going to is maybe 20, 30, 40 microns, 50 microns at most. So I'd be very surprised if it would have any actual impact on the performance of the nib. I think in the olden days, certainly, olden days, way back when, the era of the Watermans you're talking about, nibs typically used to be stamped, right? Because, lasers didn't exist. So I think the stamping definitely is much, much deeper. It's of the order of probably, 0.1, 0.2, maybe of a mil as well. Maybe not 0.2, but so that you might imagine could have some impact. But I think
part of my observation was based on some BOK 380, the size 8 nibs, the titanium ones. Because the first one I bought has the BOK stamping on it, like, pure BOK kind of stuff. Then the second one I bought was from William Shakur, and his only has a laser etching on it.
Right.
His was much softer, and the Williams was a medium, the BOK one was a broad. And it's kind of, they feel like they're totally different kind of nibs, from different manufacturers. And then I bought a fine with 0 on the nib at all. And that's kind of really soft. So it's kind of got me thinking that, probably laser etching, as you say, it's so fine, it possibly doesn't do anything. But then possibly the heat from the laser does create some sort of structural change.
No, I mean, I don't know. I must admit I haven't looked into it. So, but it's unlikely. I mean, you know, the laser etching process is very, very quick. Like it's, you know, it's in there under the laser for maybe not even a few like 4 or 5 seconds maybe. So, you know, and you know, these materials, you know, titanium or stainless steel tend to be very, very good conductors of heat. So the heat would dissipate quite quickly. So in fact, one of the problems that we have, I was testing one of the gold nibs with engraving, it was because the surface of the gold was so highly polished and so reflective, you know, you had to really turn the power up on the laser. So I don't think it's a heat thing either. My suspicion, and I mean, this is just a hypothesis, when you describe the 2380 nibs, I think it's just about tuning. Maybe William or somebody took a look at the nib and put a little bit of effort into getting it, you know, sorted out before sending it out to you. No?
No, that's the hilarious thing. That I bought my pen from him at the pen show, and as he was sort of chatting to me, opened up these 2 bags, took a nib out of one, the feed out of the other, without even looking. He was kind of looking at me, and he was crimping stuff, and I was like looking at this nib, going, "Oh my God, how's this going to behave?" You know, no heat setting, nothing. I came home, inked it up, kind of thinking I'm going to have to phone him and say, "Do you mind having a look at it?" And it's like one of the best nibs I've ever, you know, I've got. It's astonishing. Yeah. So yeah, it wasn't even that. It's but yeah, I just thought I'd share my observations just in case it's an interesting avenue to explore.
Yeah, no, it's really interesting. I think one of the things that I'm interested in doing, and I have been doing with some of my nib geometries, is laser ablation. So taking off a complete layer of material from the underside of the nib using lasers. And again, the idea there is very, very simple: tuning the geometry of the nib. So just you know, reducing the weight of the material that has to be moved out of the way effectively when you flex the nib, so it makes it softer. So I find that if you ablate or remove some of the material, effectively reducing the thickness of the nib, you are able to achieve that softness in the flex. And what's really interesting is, again, you know, maybe even 10-15 years ago, the precision control for lasers and the power for lasers didn't exist to be able to do that. But one of the hypotheses that I'll be testing early next year is to continuously vary the surface thickness of the nib. So the problem is, if you make the nib super, super thin, then it becomes super, super brittle, and it's very likely to snap, crack, break. Bad things will happen, right? But if you can continuously change the thickness, so across the top surface, horizontal, it's quite thick, so it has enough material to be strong. But as you move across the radius of the nib to the shoulder, you start to reduce the material. So when you're flexing the nib, there's less material or weight that you need to move out of the way, but you still have a sufficiently rigid structure because of the radius transmitting the forces. You know, the compressive forces when you press the nib down are getting transmitted like an arch essentially across to the top of the nib, where you've got that thickness that's able to sort of withstand that. So this is something that I mean, in theory, the equations make sense. It's logical, but in practice, it probably needs to be manufactured and tested. But I guess what I'm trying to say is that the technology is here now, where we can quite easily do that and just test it.
Have you tried to play with nibs like the ones that they've seen some American guys making cuts on the nibs, and the cross flex nib, for example, that Noah made? I'll send you mine. Noah made me one. It's stunningly flexible, so you can have a look. Yeah, Ralph Hayes. Yeah, so have a look at those as well. They change the geometry quite well, and they flex really, really nicely.
Yep. So that's exactly right. I mean, basically, the distance from the
Sorry, Sunil, just 1 second. I think a few people are starting to leave. So what I'll do is I'll quickly announce the winners so that everyone's here.
Yeah, sure, of course. Yeah.
And then we can go into it. I want to know more, so I want to continue, but we'll just announce the winner. So there were 32 people taking part in today's talk, and out of the 32, I've done a random number generator. And the first person for a gift from Sunil, whether that be the prototype pen or some nibs or whatever you choose, Sunil, that'll be Mick. So you've won the prize, Mick. Congratulations. And then the bottle of ink is going to Linda. So we'll get some addresses out to myself or to Steph but congratulations. And what I'll do is I'll perhaps, Andrew, let me know if the recording's too long. I don't know if you want to continue recording, but we are still recording.
No, the recording's fine.
Okay.
I can go to any length on YouTube.
Perfect. In that case, then we'll record the questions. I think it'd be quite interesting to hear your thoughts on the geometry. All right,
Yeah.
I'll hand back over to you.
Thank you. And thanks, guys. Sorry, you've been super patient. I've been jabbering on for I don't know how long. So yeah.
Super interesting. Stop apologizing.
I've got a question. If as you're making your own feeds or trying to using polymers, the one you showed us has got fins on it, but fins are purely aesthetic. Have you ever thought about trying to instead maybe do a shape which fits more with the shape and ergonomics of your actual pen? So it's more in keeping with your own design flavor,
yeah, I
rather
mean,
than...
Absolutely. So, exactly like with the nibs, but, when I was prototyping the feeds, there was a lot of the geometry that I was playing with. I found, so with the fins, I actually have their fins angled slightly downwards on the feed. It's a small angle, about 9 or 10 degrees. But I think the logic there is the fins are helping. I think they're helping with increasing the surface area. So effectively, what tends to happen is, because the surface layer of the feed is hydrophilic, it holds a fair amount of ink on it. And if I can maximize or increase that surface area, not only does it act to channel the ink through in a timely fashion, in a responsive fashion to the tip of the nib, but it also actually holds some amount of ink within the feed, almost like a buffer, So even if you, for example, were to pull the cartridge converter off the other end and just keep writing just with the feed, you'd be able to go a good many lines of writing simply because there's all that much ink that's held in the feed itself. So for me, that's what I found to be the value or the use of the fins, just as a method of increasing surface area. But I do agree with you that I don't fully understand why. I mean, I don't think that other than that, so for example, if you had injection molded plastic, I don't understand what the purpose of the fins are necessarily. And I think they kind of are from the era of ebonite, where maybe it was exactly the same thing, which is the surface of ebonite does hold some quantity of ink. So maybe it was about maximizing surface area. I don't know, is the short answer. Just to go back to Bernardo's point about the nibs and the geometry of the nibs, the cross cuts and stuff like that. Essentially, just by applying the physics of the forces, one of the things that's very simply and immediately apparent is, so if you think about the nib, the shoulder of the nib is basically effectively a tangent that you draw across the shoulder along the shoulder of the nib would be perpendicular to a tangent that you draw across the top of the nib, right? So what I'm trying to say is that the nib turns pretty much 90 degrees, and the distance between the slit and the shoulder, the curved distance along that radius, is the degree of flex or the softness of the nib, or the force required to spread the tines, is a function of that distance. So if you cut a cross slit in the nib, effectively what you're doing is you're reducing that distance, because we're now measuring that distance from the shoulder of the nib to where the cross slit ends. So you're reducing that distance, and thereby reducing the force required to spread the tines apart. What you're also doing is you're reducing the material integrity of the nib. So you're making the nib effectively more prone to breaking. So it's about finding a geometry that balances those two opposing tendencies.
It's like you said earlier about the more you modify the nib, the more it's harder to use as well, because it becomes so soft that it becomes unmanageable to use as well. One of the things I wanted to chat to you, the other thing I've seen recently is hammered nibs.
Thank you very much.
Modified
Thanks,
basically the thickness of the nib by hammering it, making it softer. And it's really interesting to use, but like you said, it takes practice. So I don't recommend it as your first use nib, but it's worth trying as well if you wanted to have a go.
Just a quick observation. I think it is actually, regarding the nib feed, I think it is the fins, the surface area, And what you were talking about earlier on, the flow of ink and the flow of air to push the ink out. I think it would be really interesting to get someone to actually look at the ink flow and, you know, use some just sort of tag dyes to look at the flow of the ink under a microscope, you know, how you do it, because, you know, you've got, you know, with microscopes, the depth of field is so shallow, you know, it'd be difficult, you know, you'd need to have sort of like different scans at different levels. But I think what you've touched on is right. I think the trial and error of previous manufacturers has arrived at an optimum of those fins. So I don't think it is just sort of
Aesthetic.
fashion or aesthetics. I think it's actually functional, not aesthetics. So, sorry.
Yeah, I mean, that's a really interesting observation. And I think one of the things that I did actually, that was exactly what I thought. And I did try your point about a microscope or watching the ink flow. And I don't have one right on my desk, but when I machine these, feeds, I machine them white. And I was just using the old-fashioned way of actually watching with my eyes the ink flowing through the nib, and the ink acted like that tagged dye that you described, because it was colored, and you know, it would sort of saturate the feed, and you could actually see it, you know, progressing across over time. And then, you know, I put up a couple of videos on Instagram, and I got the classic reaction from people. They're like, wow, a white feed. I've never seen a white feed before. I want one of those. I was like, okay, I didn't really set out to make white feeds. I set out to see what the ink was doing on the feed.
Yeah, the viscosity of the fluid should be, you know, quite, you know, similar within a margin. So, you know, the flow should be, you know, fairly similar-ish, you know. So yeah.
Yeah.
I mean, some of your observations also about, you know, where earlier on about, you know, humidity, the type of paper, what the paper is doing, etc. I think that those things, and also the surface of the paper, I think, as well.
Yeah, I mean, it's fairly non-trivial, and you know, when I started doing this, my tendency was to, you know, let's write a set of equations to understand how to make a nib flex and how to make ink flow, and I started doing that, and I very quickly realized, oh shit, viscosity, oh shit, surface tension, oh shit, something else, humidity, you know, air pressure. Then, you know, I went down this route a little bit, and then I realized how silly of me. There's bidirectional fluid flow. There's air flowing back in as well. And that was the point at which the equations went out of my, you know, beyond my sort of skill level or whatever. And I think, you know, I trained as a chemical engineer, and I did study at uni, you know, fluid flow as one of the subjects. And
yes, but I started off a long time ago as a chemical engineer, but I stopped.
Yeah, same story. I mean, I graduated, but I never really practiced as an engineer. I ended up doing something different. But one of the things that you see, you know, with Navier-Stokes and stuff like that, with the Navier-Stokes equation and stuff like that, is very quickly you come into regimes where the fluid flow is not laminar any longer.
Yeah.
You know, for a variety of reasons, and you know, pretty much everything in real life, in nature, and so on, doesn't obey the Navier-Stokes equation. And all of us engineers, we just say, if you disregard this factor and that factor and ignore humidity, then we have the Navier-Stokes equation. And look, I can predict this fluid flow. And you're like, yeah, great, but it doesn't work like that.
Yeah.
So, you know, I think essentially what I'm trying to say is that there is a lot of engineering by trial and error that's needed here. And I'm also trying to say, I think it's a lot of fun. You know, I mean, again, if we didn't want all of this shit, there's a very simple solution, right? It's a ballpoint pen. It works. There's only 3 variables. Happy days. You know, use it all day long. You uncap it. It starts writing. The line is exactly the line. You know, off you go. So I think, you know, we gravitate to this complexity as human beings, as fountain pen fans, or whatever you want to call it, because we like that complexity. We like to dive into it and think about it and test it. And you get this gratification when it works. You're like, look at this. It's looking so beautiful. I put a huge amount of effort in to get to this point, rather than I just uncapped the pen and it's so beautiful. You're like, not very satisfying.
Is there any opportunity to actually do ink simulations on a computer? Has anyone ever thought about that at all? Or is that something which would be impossible?
No, it's not impossible. It's actually, it's fairly doable, I think. we do for materials. We like, for example, with the design of the pen, the object itself, we do a finite element modeling, which basically models stresses and strains while machining and in use. So a very similar kind of see you, Jim. A very similar. Oh, I don't know if you're doing something else. A very similar kind of approach, but I think essentially, most likely, Andrew, what you'll realize is that very quickly, it's not laminar flow. It's basically it's in a turbulent regime essentially. And what that means is that if you have a very slight variation in your starting point to that equation, slight variation in the temperature, for example, then the outcome that you get would be significantly different. So it's not a linear thing where you say, oh, I change this variable by 1 unit, then my output changes by 1 unit. It's I change this variable by 0.01 unit and my output doubles or halves. And it's unpredictable whether it's going to double or half. So I think that's basically what's happening with the ink flow in my, it's a hypothesis. I don't have any proof for this. But yeah, you probably can run some of these simulations. I guess the question is who's going to program something like that?
But it's infinitely, well, almost infinitely variable, isn't it? Which kind of adds to the fascination of the hobby side of what we all do. You know, which ink are you going to use? Which brand? And then in that brand, which color? Because everything behaves slightly differently, right? As you're saying, the smallest variable is going to multiply. The end result's going to be massively different. So at least temperature's constant. Well, temperature's just one scale. But then, you know, you've got diamine with, you know, 200 inks or whatever, and then each one is slightly different. And then you've got, you know, pilot and blah, 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 and blah, blah, blah. Yeah, it's interesting.
Yeah, I mean, I think basically you know, if you really wanted to do it, the way you do it was you'd list out all the variables that impact that ink flow, you know, whether it's, you know, temperature, density, viscosity, surface tension, et cetera, you know, pH, whatever. And then you'd basically write a series of equations, or like Andrew was suggesting, you'd model fluid flow to arrive at a series of equations that would describe that fluid flow behavior. And then you can plug in whatever ink you want. So you'd plug in diamine golden sands. And you say, okay, you know, it behaves like this because the particles are, you know, 10 nanometers, or I don't know what size, not nanometers, maybe micrometers, whatever. And off you go. But again, you know, it's like, I think Jim or somebody else was asking the question, how hard do you press the pen? And okay, 300 grams of force at 45 degrees means bloody nothing to me. You know, I don't put my pen on a weighing scale and, you know, paper on the weighing scale and write. No? So I think that's where the problem comes, right? The translation. And you have to do that by feel, right? You come, you use the nib, and I'm sitting with you maybe, and I say, push it a little more, man. And you say, are you sure? I'm like, yeah, go for it, man. And then
it's
you're like,
same
oh, wow,
question
cool.
I get asked as well about, like, if I'm talking flex nibs to someone else, like, how hard do I press it? Because they're scared of springing the nib. The best advice I think I've given, and it has worked, you know, you do the loops, the figure eights, do them really slowly and start with like kind of the slowest pressure, slowest speed that you can. And then, you know, you won't spring the tines if you do it really, really slowly. You have that breathing space to actually recover the nib. That would be my advice.
Yeah, definitely. That's really good advice, actually. And you have much more control when you're going slow as well. So if you feel that it's going off, you can just pull back quickly. Yeah, and I 100% relate to the comment that you made about watching the ink pool and getting that shading and the shimmer and whatever. You've got the properties of the ink. And I'm a problem solver. That's my job. That's what I do day to day as well. So this is how I love the hobby, because every ink in any pen that I put in reacts differently. And they won't work. Some 100% will not work, even in a perfect working pen. The inks is just the problem. But you try and error. I like it. It's interesting. Sometimes when the sun shines, I just like to write, and I just watch the ink. Are there any more questions? Okay. In that case, what I'll do is I'll stop recording. We all tend to stay, Sunil, just to chat a bit longer. So if you want to stay, you're more than welcome to stay. But I think we'll stop recording at this point, and then we can continue. Cool. I'm just gonna. Thank you so much from everyone, though. I'm leaving. Thank you, guys. I'm sorry. I hope you don't get too bored because I just feel like,
No, no,
I droned on for quite long.
That's
Honestly,
fascinating.
this number of people would not stay if you thought that they would be joining on, and
No,
you
I,
actually
I,
got
I
a
think
good
that
discussion going.
I think they stay because they're kind and they feel, awkward to leave. So
just to use the vernacular here in Gaelic, there's a word called muggerly, which translates as bollocks, so sorry for that bit of rudeness. There's just an interesting word which I've written down, what you were talking about, ambedo. They were talking about that, day of the sunshine. And I wrote it down, it's a kind of melancholic trance in which you become completely absorbed in vivid sensory details, raindrops skittering down a window, briefly soaking in the experience of being alive, an act that is done purely for its own pleasure. That's what you sort of described. And I think it's the intangibles of writing that, no matter how much, even if you're a geek, and most of us are, no matter how much modeling you do, it's that sort of intangible sort of like, this looks good. Yeah. And it'll all come out different on a different day.
it's very